So hi guys. In the year 1836, British chemist John Frederick Daniell invented a type of an electrochemical cell known as the Daniell cell. In this lesson, we'll take a close look at the components of these cells and also describe how it functions. Now here is a simple diagram of a Daniell cell. As you can see, the cell is a copper vessel which contains a concentrated solution of copper 2 tetraoxosulfate 6. A porous pot containing a solution of zinc tetraoxosulfate 6 is also placed inside the copper vessel as seen here. Inside the zinc tetraoxosulfate 6 solution is a zinc rod which acts as the anode or negative electrode, while the copper vessel itself acts as the cathode, that is, the positive electrode. Now, let's describe how the cell reacts. As explained in earlier lessons on the setup of an electrochemical cell, the atoms in the zinc electrode undergo oxidation by losing 2 electrons, which flows out through an external conductor to the cathode. Also, at the cathode, which is the copper vessel, the copper ions in the copper 2 tetraoxosulfate 6 solution undergoes reduction by accepting the electrons flowing in from the anode. The porous pot in the cell acts as a porous partition or salt bridge, which prevents the two solutions from mixing together. It also allows for the free movement of ions between the copper 2 tetraoxosulfate 6 and zinc 2 tetraoxosulfate 6 solutions. To illustrate the movement of these ions through the salt bridge, let's use a much simpler model of the Daniell cell shown here. The salt bridge used here is a filter paper soaked in potassium chloride solution. Due to the reduction of copper 2 ions in the copper 2 tetraoxosulfate 6 solution, the solution becomes more negatively charged. The salt bridge helps to neutralize this effect by allowing tetraoxosulfate 6 ions to move into the bridge while allowing its potassium ions to flow into the solution. Also, due to the oxidation of the zinc rod, the number of zinc ions in the zinc tetraoxosulfate 6 solution increases, and this gives the solution a net positive charge. The salt bridge neutralizes this effect by simply allowing some of the excess zinc ions in the solution to move through it, while also allowing its chloride ions to flow into the solution as shown here. The movement of these ions through the salt bridge is very important because it helps to maintain the electrical neutrality of the solutions in the cell. This movement of electrons in the cell produces about 1.1 volts of electricity and is used to power our torchlights and radios. Let's do a quick summary of what we've learned about the Daniell cell so far. The Daniell cell is a copper vessel which contains a concentrated solution of copper 2 tetraoxosulfate 6. Inside the vessel is a porous pot containing a solution of zinc tetraoxosulfate 6. The copper vessel acts as the cathode, while the zinc in the zinc tetraoxosulfate 6 solution acts as the anode. This is all we have to discuss about Daniell cell. I'll see you in the next lesson.